Hello, hi guys. My name is Femi Aishiro, and in this course, we are going to be focusing on getting started with Go, the basics of Go. That is our focus. And if you have not subscribed, you have not liked, please consider doing that for subsequent videos because I'll be uploading more videos on the channel. I'm doing this course as a follow-up to the course I did on building a CRUD application, and I want to do this because to just bridge the gap. If you're new to Go or you're coming from a different language, you cannot just start building projects. There's a need for you to go through the basics of the language so that when you start building projects, it becomes a lot more easier for you. All right, so we're going to be looking at the basics. What are the things that we need to do? What are the things we need to know? And I'm going to make this course to be a series. Okay, it's going to be a series course, and the focus for this first video is to get our gadgets set up, the things that we need to know, the basics. We are going to talk about setting up your system, getting the integrated development environment, getting an ID on your system, an environment where you can write the code. We're going to talk about variables. We're also going to be talking about pointers and then importing modules, and those just basic things. These are just basic things to set up our environment. And then the subsequent videos, I'll move into talking about functions, talking about arrays and map, and talk about slices. I'm also going to be talking about structs and the method of structs, the receiver method. I'll also be talking about interfaces and all of that, so error handling. So there are a lot more that I'm going to be discussing in this series. But the focus for now is to get our system set up for the series. And the first thing we are going to do is to go. I've also prepared a document. So this document covers everything we are going to be doing in this series, entire series. So I have the document prepared, and we are going to follow the document. We are setting up our environment. So what do we need to do first? So what we need to do is to have Go on our laptop. So that's the first thing to do, and we are going to download Go because we don't have Golang on our system. And maybe let me just do a brief description. So what is Go? Go is a programming language. It is developed by Google. Very fantastic language. Go is versatile. It's used in networking space. It's used in cloud. It's used in backend. It's used in building too. So it has a lot of usefulness in many areas. All right, and then one thing that makes Go unique is it's also very fast. It's also a very fast programming language. All right, so let's get ahead to set up and have some setup on our system. So the first thing is we are going to install Go on your laptop. So we are going to come here. I'm going to click here. So this is a site officially from Go where you can download Go. You need Go on your laptop in order to be able to run Go on your system. That is very important. And we are going to download it here, so you can click download. I have done that. And once you are done downloading, the next thing we have to do is to check. So it says verify that you have installed Go by opening a command prompt and typing. So how do we know that you have successfully downloaded or you've installed it? We have to come here and check using Go version. So I'm going to do that right now. I'm going to go to my terminal and we're going to do Go version like this. So by the time you type in Go version and it brings out something like this, it's going to give you a version that is installed on your laptop. So once you have this, it shows that Go has been installed, right? So you can see that the version I have here is different from what I have here. But what matters is I have it installed already. Okay, so that is that. And I'm going to talk about very quickly. We have a playground. So the playground is something online, right? You don't need to do anything. You can open your laptop and just go on the site. All you just have to do is to make sure that you are connected to the internet. So what is this playground? So the playground is a place where you can play around with some of the basics. You don't need anything. You don't need to install anything. Just come here and run some code here. I mean, maybe for instance, I can just do fmt printing like this. Let's say hello. Welcome to Go. Basics like this, and that's all I have to do. Welcome to Golang basics. So by the time you click run, what you have is you have this printed, so you can start learning some things using the playground. Just play with some syntax of the program, write some stuffs, and you're going to get the results right here. So it's a very useful place for you to start learning Go and practicing and trying out some things. So I also recommend this. Okay, so but for a bigger project, for a more robust project, it's important that we need to have some things installed on a laptop. You can do a big project just having this online. This is not a suitable environment. How we recommend that you have an environment where you can conveniently write your program. And I have three recommendations here. The first one is a Visual Studio Code. I have Z and I have JetBrains. So I'm going to open this and let's see what we have here. So this is Visual Studio Code. So this is what I use particularly. This is a project I worked on. It's on the platform, the tax application app that I worked on. And you can see that we have several folders and files. We have a lot of folders and files. And if you're building such project like this, definitely you can use the online playground. So you need to have an environment where you can conveniently start your project, and you don't even need to be online in order for you to use the platform. I mean, in order for you to use the ID, this requires that you are online. So I'm going to close this. You can go ahead to download this for your environment. And after you're done downloading, and the next focus is going to be that we want to create our Go file locally on your laptop. That is going to be our focus. And what we are going to do now is I'm going to open a new, let's open a new window. I'm going to open a new window like this. This is a new window, and let's create a folder. I'm going to create another folder. I'm going to come to my desktop. I'm just going to call it, let's say, Go Intro. So I'm going to call it Go Intro. And what we are going to do now is, let me rearrange this very well. So let's come here and open that folder. So we're going to open the folder by coming here. So it's in our documents. What we have is Go Intro. A quick observation is that we don't have any file inside the Go Intro. The folder is empty. The instruction we have is to create a new file, name main.go. And the question is, why do we have to create that? There's something I wrote here. Main.go is the entry point of a Go application. The entry point is that is the entrance. Our code starts executing from the main.go file. You may want to check out so many Go projects. What you should see, or if it's a REST API, you will see that every of those projects has main.go. So this is officially, this is recognized. The main.go is the entry of a Go application. The Go runtime starts executing your code from the main package and the main function. So we are going to be doing that shortly. And then there's something else that we need to also take note. A Go source file have a .go extension File name typically use lower case letter. Go is case sensitive. We need to put that, we need to remember that. Go is case sensitive. So I'm going to creating a file here called main.go. We are going to write our program very shortly, but something I want to point attention is that the extension has to be .go. Whatever name you're giving to your file, whatever thing you're calling your file, the extension has to be .go. Since you're programming in Go, it has to be .go. So what we have .go. You can see that every files that we are creating here ends with .go. Every file we are creating ends with Go. That is a convention, and it is lowercase letter. So it's recommended that when you're creating your file, it should be in lowercase letter. I mean, these are things that you can always verify and check for yourself. They are everywhere online. So the next thing we are going to do now is to start up. Let's create our first program and let's run the program and see if it's working. What we are going to do now is we're going to write package. I'm going to be explaining everything I'm typing here one after the other shortly. Package main, and we are going to do func. Unlike other programming language like maybe JavaScript, you have to write function, but here in Go we don't have to write the complete function. We just write func main, and it's also very important to take note that our main does not take in any argument. We don't pass in any argument. We just have to write it like this, and then parentheses, and then we open our braces, and that is all. So this is all that you need in your main.go file. I'm going to import a package called fmt.printin. This package, what it does is to print to the console. That's the function of this package. It's just to help print to the console. I'm going to do hello welcome to Golang basics, and that's all that I want to do. So the next thing is we open our terminal and we are going to run the code. So the command for running your Go or executing your Go is to write go run main, the name of the file that you want to run .go. So we are starting with main, and that is the convention. So go run main.go. By the time you click, what do you have? You have hello, welcome to Go basics. Congratulations, we have written our first Go. Now this is locally on my laptop, right? We don't need to, you don't need to be connected, even whether you are not connected online. And since you have this now, that means you can create more folders and more files and all of that. So that is that. Let's come back to our document. The next thing we want to focus on is understanding packages, right? You may want to see that we use the package main here. I mean, what does it mean? Okay, so I'm just going to explain that a package is a collection of Go source files in the same directory. A package is a collection of Go source files in the same directory that are compiled together. So what they are talking about here is that I will make reference to an old project. When you see this project, the CMD is a folder, right? You can see it's a folder. Internal is a folder. Web is a folder. Inside the CMD folder, you can see that we have 3 different files inside the same folder. So we can say this is a directory. CMD is a directory that has 3 files. And I'm going to start from the main. So we go back, when we check the main, what do you see on top of it? We are seeing package main. If you come to the handler, what do you see? You are seeing package main. If you come to the API session, what do you see? You are seeing package main. So what you are seeing there is that the file system, right, is a collection of Go files under the same directory. That is the first thing that we should take note. Every code that I've written inside the API okay, the ones I've written inside this handler, I can as well delete them and put all the code in the main. Everything will still work. But in order to just keep the code simple and not have a long code, that is the reason why I have decided to just separate it and then separate it into different files for organization and then to make the code readable. That is the essence of doing that. But they are all in the same directory, and that is why they carry the same name. So packages are meant for organization. Packages are meant to organize our code. Is a collection. You can see that a package is a collection of Go source file in the same directory. They are compiled together. Package help organize your code logically and promote code reusability. So packages also helps us to reuse our code. And I'm going to still give us an example here. In the internal folder, you will see that I have different folders under it. So the folders I have here are being used in the CMD directory. So all the things you are seeing here is being imported here. We have the DB. Under DB, we have things that I've written here. Whatever I've written here is being used in my main, is being used in my handler, is being used in my API. And let's talk about the repository. The repository also has what? Two files. You can see that they also have the package repository. We also have what? This as well. What am I saying is, I'm saying that packages is just to organize our code. You will see that on this project, we have different packages. Okay, so this is a package CMD. We have DB is a package model, and then we have repository. Is a different packages from their names. You see that this is a package repository. The model, this is a package model. So different packages having in a project. Okay, that is that. So how do we now use package? Okay, you will discover that this is a package main, and then I'm also importing. So what is the essence of the import? You have package. So package are more a way of organizing our code, right? And the essence of that is that whatever you have in a package, it is possible that you write a code in a particular file and you need that code in another file. So what do we do? So I have a code in this particular package. Let's say the code here I've written in this package repository. I also need it where? I also need it in my main. So what do we do? In that case, what we do is to import it. And that is why you can see the word import. So packages have to be imported in order to be able to use the code. So if you have two different packages and you need a code from another package, you have to specify by importing the package. And for instance, we can see that we have the FMT. The FMT package is a package that is coming from the Go standard library. We have the Go standard library, and I'm going to be showing us that. So we have FMT is a package, and the code we need is print in. So in order for us to use printing, we have to import the package, and I'm going to show us now. So I'm going to click on this, and let's go to, you can see that this is a function that is written under print.go. I want us to take note that the function starts with the capital letter, because that is also very important. We are going to be talking about the rule, the visibility rule, very shortly. If you go to the top, at the top, what do you see? You see package FMT. So this is a package from the standard library. This is inbuilt into Go. So whenever there are basic things you want to do in Go, we have a standard library with a lot of code. So you can just import that package, right? And we have FMT. Okay, so we have FMT, the package, but inside that package are a lot of code that has been written, functions that has been written, method that has been written. So when I need something in that package, all I need to do is to make reference to that package and then call the name of the function that I need. This is we importing from a Go inbuilt standard library. We are also going to create our own several packages, and I'm going to be showing us how to import from our own packages as well. You can see that if I click here, print, and then we get this out of the box for us. So that is that about packages. Okay, so if you want to read more, I have this document prepared. So we have common standard library packages. The common standard package, they are just to help us whenever we are doing. So whenever we are working, we have the net HTTP for making network calls and whatever we need to do, request and response. We have a package like that from the standard library as well. So we've talked about importing. A goal has to be, so importing is a way of linking different packages together. So packages are just standalone, collection of Go files. But in a situation whereby you need that package in another place, you have to link them together. And one way of linking those packages together is by importing, which we have already seen. This tells us that the program needs function, and so we needed a function from the FMT, and we have to import the package, and then we now did FMT dots. We make reference to the package dot the name of the function that we are calling. So we can see we have FMT dot print line. I believe this is okay now. So the next thing, so before we move on, we are going to talk about the visibility. Golang is case sensitive, meaning that when you're starting something with a capital letter, it has a different meaning from you starting with a small letter. Let's say we have not gotten to function, but let me assume I write a function. Let's say func. By the way, function is a block of code, right? So let's say FMT. Let's see. Hello, good morning. This is what we have. And we want to import this. There's a difference between writing a function starting with a capital letter and writing a function. Let's say I have another function. Let me start. So these two are different. First thing to have in mind is Go is case sensitive. The second thing to keep in mind is you're starting, there's something we call identifiers. We are going to get to that shortly. When you're starting with a small letter, it has a meaning. When you are starting with a capital letter, it also has a meaning. We will see that when we import this print from FMT, it is starting with a capital letter. If it were to be a small letter, it will not be possible for us to be able to import. So that's the rule. So, okay, so when we start, packages expose their code object to that package based on the identifier name. So identifier name is a name given to whatever. It could be a function, it could be a variables, whatever we are going to do. Whatever you do has to have a name, right? So the name you give to something is the identifier. We'll get into that briefly. If an identifier could be a constant variable function, start with an uppercase letter. Start with the uppercase letter. It is exported and visible outside the package. We understand what a package is. A package is, you have, in a package, you have codes that will be written. You are going to write a lot of code. Maybe you have a function, whatever you have. If you start with the uppercase letter, what this line says that when you start with the uppercase letter, that identifier becomes useful outside of the package. It means you can import it. I'm going to be showing us briefly. So, very important, we need to take note that Go is case sensitive. The next thing we are going to be talking about is modules in Go. We've talked about packages. We can have different packages. And I'm going to do something here. I'm just going to do internal. This is also common. It's a convention. Inside internal, I'm going to have another folder called, let's say, DB. Let's have another folder. We're going to call it repo. Alright, so inside the DB, we are going to have a file. We are going to call it db.go. Inside the repo, let's have another file. Let's just call it repo.go. Alright, so we're going to write it a package repo. The convention is that the name of the directory of the folder should be the package name. Go as well, we are going to have package db. You can see that red line has gone. Alright, I think we are good now. Oh, I didn't name this correctly. This should be db.go. Alright, so we are good now. So let's talk about modules. Right? Let's talk about modules. What are modules? A module is a collection of the related Go packages. Collection of all the Go packages. Because in your project, it's possible to have a lot of different packages. In this particular project, what we see is that we're having a lot of packages. This is CMD. We have internal, we have DB, we have model, we have repository. So it seems to have a lot of packages in this singular project. A module is a combination of that packages version together. For this project now, right, a combination of its version together is what we are referring to as a module. So a module has all the packages combined together as a unit. That is what a module is. It provides dependency management and version control. How do you now know if your project has become a module? How we get to know that is we are going to have go.mod file. Go.mod. This is a file that will be created for us when we have to initialize that project. Right? We need to initialize that project. It is when we initialize the project that this file will be automatically created for us. And I'm going to be taking us through that process shortly. When you are working on an application, you will need code from people. Let's say you're building an application. There are certain problems, there are certain issues that you are going to face, that there are a lot of solutions done. Maybe somebody has written the code and all of that. So most times when you are building a project, you are building an application, you need input from other sources, a third party and all of that. Maybe you need a library, you need validation, you need a router. You will need to import the existing libraries that we have, right? So what we need, one of the reasons why we need a module is because it provides dependency management and version control. That it helps us to keep tracks of those things, those dependencies that we used in our project. If you look at this project, you see that I use a chill library, and with the version, I use CORS, I use SQLite. So this project keeps track of the libraries that are installed in the project, because the library are being used for one functionality or the other. The module is what takes care of that, and then you have the version. So it's like the node modules or the package.json if you are coming from the JavaScript ecosystem that keeps track of all the dependencies, whatever dependencies that you install. And let me just quickly show us. This is a full stack project. We have the package.json. So you are seeing that the package.json keeps track of whatever dependencies, whatever things we use in our project, whatever external resources. This is just a place that keeps track of those things, and that's the same thing that a module does for us. I hope that is clear. For us to have a module like packages, we had to do it ourselves. For modules, we have to initialize. Okay, so for a singular project, you can only have one module, just a unit. So it takes care of all the other packages that you have installed in your project. So we have to initialize. And when you are initializing your project to be a module, you also have to provide a path. That is very important because when you are installing packages, that path is what we are also going to be making reference to. Let's initialize our project to be a module. And what we are going to do now is to write this command, go mod init. This is just what we need. Okay, so you can give it any path name that you want. So we are going to do go mod init like this. I'm going to do the path name is going to be git hub.co/golang basics. Once you are done, just click enter. What's the observation? The observation here is that there's a go.mod file that has been created. You can see a go mod file that has been created, and it's giving us what? The roots part. So whatever dependencies, we have several libraries in Go. Let's say I want to use Chi for routing. So this is a particular library in Go. If I want to use this library in Go now, you can see a lightweight, idiomatic, composable router for building Go HTTP service. So you are building HTTP service, you need a router. So this is a library. If I need this library, all I need to do is to get the library and then install it. Once I install it, the version of that library is going to be here. You can see that my Go version is also here. So this just helps to keep track of whatever things that we are installing in our application. And I know that as we begin to interact more on building many other projects, we get to understand this more. So that is that. And then we have go dots. So when you want to get the specific dependencies, what you have to do is go get the name of the dependency. And if you have a lot of external library installed, used, and you have not installed them, you can use go mod tidy. It will just automatically install all of them instead of trying to install them one after the other. So we are going to stop there for now. Another very important thing that we need to talk about, I made mention of this before, is identifiers. Identifiers are the names that you give to the things you're writing. Your variables, your function, definitely they need to have a name. So identifier is that name, to identify that. An identifier is a name assigned by you, the programmer, to program elements like variable, function, template, struct. You're going to understand what this means later. Go is case sensitive. A valid identifier begins with a letter. And we also have a blank identifier. We are going to be seeing this in the course of our study. So a blank identifier starts with an underscore. When a function is to return something, so a function that is to return something, and you don't need the value that is being returned by that function. So what it means is that it's just like you go to the ATM, you need money, right? So let's say you go to the ATM and maybe you just want to check your balance. You don't need money. So you just check your balance. You're not collecting money. Some other people go to the ATM or go to the bank and they collect money. So the blank identifier is, we don't need the value. So instead of leaving it blank, we just use a blank identifier. What it means is that, like other identifier can be used, its value is discarded. We are going to see this and cannot be used. So we are going to be seeing this when I'm writing code so that we understand better. But I want us to take note that we have a blank identifier. Let's talk about the basic structure of a Go program. Program consists of keyword, constant, variable, operator, types, function. Common delimiters, you're going to see parentheses, which we have seen it already, braces, and we are going to see brackets when you use arrays and slices. These are things that we are going to be seeing. What we want to do now is very, very key, and that is we are going to start to talk about what we refer to as variables. And I'm going to show us a diagram here. So what is variable? When we say what is variable, in Golang, we have two ways of declaring variables. The first one is we can start with the keyword var. So if you check here, we have the keyword var here. You can check, we have the keyword var. Okay, so we start our variable declaration using the word key, the var. Whatever you put, whatever comes next is the identifier. You can see the identifier that I talked about. Identify. It could be any name to identify that variable. And the next thing that follows is the data type. So you see that we have the var keyword that shows it's a variable, the identifier, and the data type. What is a variable? A variable is a container that holds something. Across every programming languages, you always have to use variables. Variables are seen as storage that contains something. That is what variables are. It cuts across every programming language. What makes this peculiar in Go is we have interpreted languages like JavaScript and Python. We have statically typed language, Java, Go. When we declare a variable in Go, it's important that we also specify the data type. So when you declare a variable, you also have to specify the data type, and that is what we have done here. So we are saying the data type here is a string. It could be anything that you want. I'll come back to that diagram shortly. Variables holds data, and data belongs to different data types. So variable as a container, it's such that you can't just put anything inside the container. I mean, you have different containers in your houses, and they are for different purposes. The same thing too, we have variables. What kind of data we can store has to be, we have to specify it. I want us to take note of that. So it's a statically typed language, meaning that the compiler must know the type of every variable. That is very important. The next thing is we are talking about type definition. A type defines the set of values, operators that can be applied to those variables. When you create a variable, we are going to be working through examples shortly. When you create a variable is meant to hold data, right? The data that is going to be inside that variable or container, you have to specify, because in Go we have different data types. That is that. The next point is that when we declare a variable, so the next point in Go is we can declare a variable without assigning a value to it. So it is more like you have a container and you don't have a data. You don't have anything inside the data. In other programming language, maybe let me say JavaScript or Python, you can get away with that. But in Go, we have to specify data. When we don't put a data, once we don't assign a data into our variable, what it means is that Go will automatically assign a default value. And why is Go doing that? Go is doing that because when you declare a variable, Go automatically initializes a memory for you. So there's a memory space assigned to every variable declared in Go. These are the things we going to be showing us. So let's declare a variable and see. Everything we've been saying is theoretical. Let's just go, and we are going to declare a variable, so we can declare it outside of the main function. You can do var, the name of your variable, let's say age. That's the identifier. The data type has to be what? Int. What do we want to do? We set it to 60. Right, so when we are done, instead of using this, I'm also going to use another formatting package. We are going to do fmt print f like this. So this helps us to format this more nicely. Let me use print int. Let's use print it for now. So we are going to put the name here, age. So you see, I've declared a variable with a val keyword, identifier is in age, data type is int, and then we want to print it out. What we are going to do now is, let's run our go run min.go. What do we see? We are seeing 60. So we've declared a variable. So we can also declare a variable and say my name. Let's use string equals to, let's use Steven. So I can come here and then let me just put my name here as well. So let's do it again. What do you see? We are seeing Steven and 60. So that's variable. What I have done here is to declare a variable and also initialize it with a value. Right? I've declared a variable, at the same time I'm setting a value to that variable. Which is what I've done. But also, I've also said that in Go, you can declare a variable without setting a value, without assigning a value to it. And I'm going to show us that for that age, we are just going to see a 0. Because by default, when you declare a variable, which is an integer, and you don't assign a value, you should get a 0. What do you see? You are seeing a 0. So I'll just take us back to the diagram. So I have a diagram here that talks about the different data types. For int, the default value, in case you don't explicitly set a value into the variable that you are declaring, then these are the values. It's going to be 0, string is going to be it's going to be empty string, bool is going to be false, float is going to be dots, and then there are other ones that is going to be new. So I want to show us the data types that we have in Go. I'm going to do that right now. What we have on the screen is basic data types. Basic data types. We have the types. We have unsighted, we have sighted, we have floating point, we have complex, we have bool, we have string, we have byte, we have run. These are the data types. And I want us to take note of something. We are saying these are the basic data types. Right? These are the basic data types. You will see that all the variables are being declared, and then it is set to a value. It is set to a value. In case there is no value, Go automatically will assign a value to it by default, because there's a memory that has been initialized for this. These are basic data types. The next one I want to show us are, we have basic data types. We have composite data types. Composite is a combination of basic types. You will see that we have 1, 2. So this is more like a collection. We have array, slices, map, and struct. I'll be going into more details and explanation about what is an array, what is a slot, a slice, what is a map, what is a struct. So array is a collection and it's homogeneous. We can have a collection of numbers. Like what we have here now is a collection of numbers. Array in Go, you have to specify the length. So we mean, okay, the collection is going to be 3. And that is why you can see we have 1, 2, 3. We have slice. Slice is dynamic and flexible, but slice is built on top of array. In Go, you don't really use arrays because they are not flexible. They are fixed. Slices are more used because it is dynamic and it is not fixed. We have map. Map is key value pairs. If you are coming from JavaScript, you must have seen objects where you have a key and you have a value. You have a key defined and you have a value. Maybe if you are from Python, you must have seen dictionary as well. So we are going to look at more into understanding how to use this, passing them into functions, and the likes. The last but not the least, we have structs. Structs are for grouping data. Object-oriented programming language, we talk about classes, where you have a blueprint, a class, you define some feed or properties, and after you're done, you also have methods that act on the classes. The same thing too. In Go, we don't really talk about OOP, but we have something that helps us to achieve something like that. OOP, object-oriented programming in Go. And one way we achieve that is using structs. So in structs, we can basically create the kind of data that we want. For instance, you are seeing type person, identifies a person, name. So we have name feed, and then we have what? The data type. So you can model your own, you can model the values that you want. You can model the kind of data that you want. That is what structs are. Structs are user-defined, defining what you want. That is what structs are. We are going to get into more advanced use cases for every of them. We are going to understand them in depth. Last but not the least, we have advanced types. For the advanced types, we have pointers, interfaces, functions, and channels. These are also types. When we get to, as we move on in this series, we are going to be seeing this more. And also, in this particular series, I will also talk about pointers because they are very, very important. And we are going to be seeing them all, we are going to be using them all through the journey. So it's important that I give us an introduction to what pointers are in Go. Alright, so that is that about the different data types that we have. I want us to drop right in and let's see if we can code. That is variable, and let's finish this. We have constants. So variables are, variables can change, right? So variables can change, but we have something that is like variable as well, but cannot change, right? Variable you can assign my name to be Steven, and as I can come over and say my name is no longer Steven. Like here is Steven. When we printed it out here, is Steven. Let's say my name is Femi. Let's try and print it out here. What do you see? My name has been changed to Femi. So variables can change during code execution, but we have something that does not change, and that is constants. In mathematics, we talk about constants. Constant does not change, like pi, 3.14. Those are constants. Constant does not change. And I'm going to show us an example really quick. We can have a constant, just start with a constant keyword. Let's say pi. We're going to do 3.14. So we'll come back here and do pi. So you see that pi. So you can't come here and say you want to change your pi. It's not going to work. In fact, it's already giving me error. You can see that I'm already having a line. It says cannot assign to pi. So that is the difference. So if you know that you have a variable that is not going to change, then you can just use const for that. So that is that. So a variable is a value that can change during program execution. When declared, a variable is automatically initialized to 0. So we've seen that few points that we need to take note from here. We have a variable declaration. We can declare a variable. That is one. When a variable is declared, we can also initialize that variable. Initializing it means that you are assigning a value to that variable. So it's like you have a container and you put something inside the container. What you're putting inside the container is the value. And it's also possible to have an empty value. Right? It's also possible to have an empty container. But in Go, when you declare a variable without assigning a value, Go automatically gives it a value of a 0 depending on the data types. So different data types have a default value that is going to be assigned by Go. And the reason is because in Go, there's always a memory address attached to every variable created. And I'm going to just talk about that really quick before we talk about the different types of variables. How can I get the memory address of this variable? All we need to do is just put this and sign here and sign there. What do you see? You can see these numbers. You can see these values. So the values we are seeing shows that is the memory address of that variable. Let me, instead of saying it is Stephen, let's take this out. So that means I have variables that are declared without assigning any value to them. We come here and do go raw. What do you see? These are the memory address. And I'm going to show us that they are memory address. If I come after here, so they are just memory address. I'm going to now show us briefly something very shortly. Another thing that we have, okay, I'm going to do, let me create another variable. Let me do var show variable is equal to h. Okay, let me just do this like this. R is going to be h like this. fmt dot print R. So somebody might be like, oh, what are you doing there? I feel confused. I'm going to be explaining shortly. So I've declared another variable here. So what I've done here is this holds the memory address, but the memory address, I'm saving it inside R. Still the same thing. What do you see? You are seeing the memory address for this. Let me use the word. This is for my name. Memory address. We come back here and do. Can you see? This is the memory address for name. Then this means the memory address for age. I'm storing it in another variable. I'm going to explain this shortly. So we can also dereference it. That is the point I want to make emphasis on. So that means that it's just like you give me the address to your house. With the address to your house, it means I can find you. I can look for you. I can locate you because I have your address. So when we have a memory address like this, every variable has a memory address attached to it. When you have the address, I can get the value of that address. And how we do that is we call it dereferencing. So I can sorry about that, guys. I can dereference by putting star here. Okay, so when we dereference it, I'm going to now get the value of the age. We know the value there is 0 because it's just declared. There's no value set here. What do you see? I'm getting 0. Alright, so before we move on to discuss about pointer, I'm just going to point our attention to something very important there. And that is that we have a short way of declaring variable. We call it a short way of declaring variable. Right? So what's the short way of declaring variable? Is by declaring a variable like this. So let's just come here. We can do results. Whatever name identifier, you just do column like this and equals to. Then you can say Steven Stone. So we've declared a variable by just using this. We've actually declared that variable. But what are the rules? The rules is that when you're declaring variable like this, it has to be inside a function. You can't declare it outside a function. You know, the var keyword is outside this function. This has to be inside what? This function. And variable can be local and global. This way of declaring variable makes it global. I'm going to be showing us shortly. This guy here has to be inside the met function. So let me show us the old code. You will see that I have a lot of that. If you come here, you can see, you see the way of declaring variable here. It is inside here. You see another way of declaring variable here. I'm setting this inside this. You come here, can you see? This is variable declaration, right? So instead of doing this, you can as well do var store. So these are short ways. So, but it has to be inside a function. You can see. So whenever you have to declare a variable and it's inside a function or a method, right? So what you can do is to, if you check here, you can see a lot of ways of declaring variables, right? You can just use a short way of declaring variables and it's perfectly going to work. That is simple. So that is what I have done here. That is what I've done here. That is what I have done here. So if I come here and do, let's do FMT. FMT results. And I'm going to clear this. So let's check our console. What do you see? You are seeing Steven Stone. Can you see? Steven Stone. Very straightforward. So two ways of declaring variables. It can be a global. It doesn't mean this. You can also use var keyword inside here. It doesn't have any restriction, right? But this is simpler because, and it's straightforward because you don't have to specify the data type. Go automatically in vars. It's going to check. He knows that this is a string, so it automatically check that for you. He knows that. So that is that. And we have two types of variable, like the using var keyword and then you declaring it inside a method here. Very important. You don't declare this outside of like this. It's going to give you error. It is not allowed. It is not allowed. Two ways of declaring variable. Variable can also be global or local. So you can see that the variable declaration using this short way is local to this function. So if you want to declare a variable that is global, let's take, for instance, let's come to our repo. I can create a function, let's say a variable, let's say var my db. Let's put it as string. Let's say my db connection setup. So this is a variable declared inside another package, but I can use this variable in my main, because I also said that packages can be imported. You can link packages together. You have to import it and then use whatever code that has been created inside that package. So we have this inside this package and I need it. Let's say I need it because var with the var keyword, it can help you to make it a global. Global means it is available to any other packages on the project. So what I'm going to do now is to come here and do fmt.print, and then what do we call it? My db. I'm going to do my db. So we're going to do db dot, okay, because it's inside the db package dot my db. Can you see what I've done? let's see. So we've installed it. We've imported this. Let's go back to here. So let's copy the name. Should not be giving us that red line. Undefined. Okay, so let me just write setup. We have db dot my db. Let's run it and see. I want to see undefined. Oh, can you see why we are having the problem? The reason why we are having the problem is that it's inside the repo. I'm saying db. So that means it's going to be what? Let's take this out. Repo dot. You can see automatically it's bringing it out for me. Can you see? Imported out for me. Can you see it now? So I need the code written here in this package. All I need to do is to what? Import it. I'm saying repo is the name of the file, the package dot mb. The same thing you have fmt dot print. So you have to make reference to the package name. The package name is repo dot the name of the variable, which is what? This. You can see that's it. So if you do something like this, setup, you can see setup. If you come back here, let me see connection setup in progress. If you come back here, let's run this properly. What do you see? My DB connection setup is in progress. Right, so you can see that with the vars keyword, we can make a variable global. So any area you need it, any place you need it, you can just import it, and it is going to work for you. So that is that. And then so we have talked about the variable scope. Global scope is accessible throughout the program, which I just did. And then we have local scope, only within the specific. So this is useful only within this function. It is not useful outside of this function. I've talked about initializing a variable. So you can see variables can be assigned value at the time of creation. You declare a variable and you are assigning a value. That is initializing that variable. We've talked about the shorthand way of assigning a variable, which we just saw. That is when you have it inside a function. And then this is talking about you declaring a variable, you not giving it a value. What it means is that Go automatically, by default, gives it a default value, which we have also seen. So these are just notes. By me speaking, I've been able to explain all these concepts to us. And we have also seen the Go built-in types. I've showed us the Go built-in types. The other things we are going to be, before we stop, we have printing, right? So there are ways of formatting values. So let's say instead of writing this, instead of doing this like this, we can do fmt.printf. Printf only helps us to be able to format properly. Let's say what is my name, right? So instead of saying what is my name, we have a name here. So let me say my name equals to Steven Stone, right? So we can do, so if it's string, what's the representation for string? We can use x, integer is going to be d, right? Percentage d x. So we can do something like this. Percentage x for string, and I am the age, percentage for age is going to be d. years old, right? So we have my name and age. Just a nice way of formatting. So this one I'm going to set it to 50. I'm not 50 years. Let me just say 40. I'm not even 40. So that is that. So this is what we want to see. So if you come down here and we run this, what do we see? You can see that this is nicely formatted for us. Let me comment this out. Let's comment this out. So you can see that my name, it should be my name. I don't know why this is. Let's check it out for the last time. My name is Steven Stone. Can you see? Whatever what we set here, it's just been set here. And I am 40 years old. We can see that it's saying I am 40 years old. So this printf is a way of formatting your code. Alright, so before we go, I want to quickly talk about pointers. Pointers are very, very powerful in Go, and we are going to be using it a lot. So what are pointers and why are we talking about pointers? Let's check that out. So pointers are, in the course of our study, we are going to be, the course of this series rather, we are going to be using pointers. I said something that every variable created, variables are container. So it's like you have a lot of containers. And how do you now differentiate one container from the other if they are the same thing, they have the same color, they have the same shape? You may just number them. The memory address helps us to know, okay, this particular variable is traceable because it has a memory address. Pointers helps us, pointers holds the memory address of another variable. So what that means is this. This is a variable that we've created here. This is a variable that we have created here, right? So when we do results, I'm expecting that. What do we see? Command line argument. Okay, we have to comment these out. So what do we see? We see Steven Stone. That is what we are having here. Steven Stone. Very straightforward. Steven Stone. What I want to do is I want to create another variable that holds the memory address of that variable, and that is what pointers are. So I can, let's say, har equals to, use this sign, results. So let me print out har. This is r down here. So what do you see? I have a variable which is result. The result is here. Then I have another variable which only contains the memory address of the variable. So pointers holds the memory address. So it's in Go. We do that. We have a pointers. I showed us some of the advanced types that we have, and one of them is pointers. Pointers just holds the memory address. And the essence of doing that is because it's to be able to reference that memory. It's to be able to reference, it's for reference base. Alright, so that's why we use pointers. And in the next, by the time we get to some other advanced data types, you will see reasons why we need pointers. Alright, but I just want you to have it at the back of your mind that the memory address that is attached to every variable created can also be stored in another variable. So when the memory address is stored in another variable, we can refer. So this R now can be referred to as pointers, because I can use this R to modify this value. I showed us that when you have the memory address, then you also have access to the data. So we can come here, and how do we now have access to the data? How do we have access to the data? By dereferencing. We call it using a star at the back like this. So if I do clear now, you will see that both result and R, they have the same value. What you see, you are seeing stepping stone. So I can come here. There are cases where I can dereference like this and then set it to another value. Let's say Anthony. Anthony jacket. Do you get it? So I've dereferenced it and then I'm setting to another value. So let's see the results of R. Okay, so let's see our result of R. So I'm going to dereference again. In fact, I should have even set to another variable. Let's dereference. So what do we see? We are seeing Anthony jacket. Or let me do something here. So what are we doing here? What we are doing here is that I have a result set to a variable, Stephen, and I'm printing it here. Now, what I'm doing on line 18, what is happening in line 18 is this. I'm making a reference. I'm storing the memory address of this variable declared here inside R. So what I'm doing in line 19 is to dereference it. So when you dereference, dereference is, we do what we call dereferencing. We dereference to access the value. To access the value, access the value of memory address, because a memory address actually has a value. By default, maybe it will be 0 for integer. For string, is going to be empty string. So, but in the case whereby we have a value that is set, so we dereference to access the value. You understand? In the memory address of that memory address of the memory address. That is the essence. Now, what I've done here is this already has a memory address. This has the memory address. By using this sign, by using this, right, in front of the variable, we get the memory address which I've showed us. So I dereference it. So when you dereference it, you get the value. So here is just like saying the value. We are now changing it to Anthony jacket. So if you come back and we do go like this, what do we see? We see Steven Stone, Anthony jacket. The reason why we are seeing Steven Stone here is that we are printing it here. We have not yet changed it. Now that we have changed it, this variable has been changed to what? Anthony jacket. So we are going to be seeing how powerful pointers are. The essence of pointer is that they are reference based. I'm going to show us something really quick now before we round up this particular series. So reference holds the memory address of another variable. Go uses pointers for reference-based programming, right? And memory optimization. Why use pointers? To avoid copying large structures. So when we have to copy a large data, because when we have a function and the function is taking argument and the data you are passing is very large, because when you are passing data to a function, it creates a copy. When we get to function, we are going to understand better. It creates a copy. What Go does is we use a pointer that instead of it creating a copy, we can directly modify the data. When we get to function, we are going to understand to modify values directly. You can see that from this example, we've been able to modify this. And the next thing is efficient memory usage. So we can see that this is a var x, right? And then this is a pointer. So this is just what we have done. So we are going to stop here, and the next class we are going to now focus on functions. What are functions in Go? Because we are going to be working a lot with functions, and from functions then we can move into structs, and we can move into arrays, maps and structs, and then interface and the likes. So if you enjoy the content, I want you to consider subscribing to the channel for more, so that when I upload more videos you can receive a notification. Thank you and bye.